Welcome to Crypto 101, a first principles jargon-free course on blockchain and its impact on financial services. In the previous lesson we got familiar with Ethereum. In this lesson we will get a real-world feel of Ethereum. We will view Ethereum addresses and Ethereum transactions. Let's get started. Before we go further in this lesson, it is useful to note the role of wallets in the Ethereum ecosystem. Just like Bitcoin, Ethereum has an account opening workflow and an ongoing transactional workflow. Just as in Bitcoin, the options for opening an account and transacting on Ethereum are the same as in Bitcoin. You can run a node, use a non-custodial wallet or a custodial wallet. As in Bitcoin, running a node is for technical users only. Many users would use a non-custodial wallet and a majority of users use custodial wallets. So far, we have learnt that there are two types of addresses on Ethereum: currency addresses and contract addresses. We will now navigate to the etherscan block explorer to view what these addresses look like. First, I will navigate to the etherscan block explorer. I will then copy and paste my Ethereum currency address on the search bar. The address is pulled up. You can see one transaction that was received on this. This address is identical to Bitcoin address. We can now open this transaction. The attributes of this transaction open up on the screen. You can see the value attribute of the transaction contains the amount paid. You can also see the transaction fees charged on this payment. This is equivalent to the Bitcoin transaction fees. In the previous lesson, we learned about the two attributes: value and data. We just saw the value attribute. Where is the data attribute? For seeing the data attribute, we need to scroll down a bit. We can expand this view and see that the data attribute of this transaction is empty. This is because this is a pure payment transaction and no information is required in the data attribute. However, a payer can choose to put an informational message in this field. For instance, you could write the purpose of payment when initiating the transaction from a wallet application. We can now view a contract address on the etherscan block explorer. But before we do that, let us take a second to make an observation on the currency address that we just reviewed. Notice that on the top panel there is no contract tab. Now I pull up a contract address. On this address, I can see a contract tab. Next, we will explore this contract tab further. On the contract tab of a contract address, we can see the source code behind the smart contract. This code is in a human-readable format, though, of course, only programmers who know this language can write the code. However, this is not the format of code that Ethereum understands. If we scroll down, we can view the source code in the equivalent machine-readable format. The source code is written in a human-readable format using software applications that specialize in converting the human-readable code that we just saw into an Ethereum machine-readable format. We will now explore the transactions associated with this contract. We can see a total of 62 transactions have occurred on this contract. Of this list of 62, the first transaction is the one that created the contract itself. We will navigate down the screen to locate the first transaction. You can see the transaction description of contract creation. Let us open this transaction. The attributes of this contract creation transaction get displayed on our screen. We can see that the value field is 0. This is because we are not making a payment. We can now navigate to the data field. Next, I expand on this window. We now see that the data field carries the source code of the new smart contract. This is the same code we saw in the previous slide. The creator of the smart contract initiated this transaction. This required him to pay a transaction fees, just as one would for a payment transaction, though the amount paid is different. Continuing with our contract creation transaction, we can now view the address from which the transaction was initiated and the destination address. First, the destination address. While on the block explorer, what appears on the destination address field is the address of this contract itself. This is somewhat misleading. When the contract creator initiates the transaction, he obviously does not know what the contract address will be. Hence, the destination address input is a special address called the zero account, which conveys to Ethereum that a new contract is being registered. Next, let us look at the source address. If we click on the source address, we can see that there is no contract tab on the source address. This is because it is a currency address. The contract creator initiated the transaction and paid the fees from this address. This brings to an important learning about Ethereum. We know there are three types of transactions: payment transactions, contract creation transactions, contract execution transactions. Any of these three transactions can only be initiated from a currency address. We saw the transaction that triggered the creation of the smart contract. What about transactions that trigger the execution of the smart contract code? Of the 62 transactions we see attached to this address, only one is for the purpose of placing the software code into Ethereum. The remaining trigger execution of the code. We can pull any one of these transactions. The transaction is being initiated from the same currency address which initiated the contract creation. The destination address is the contract address where the code is residing. We can see that there is no Ether being transferred. Transaction fees must be paid for any transaction that triggers execution of the code. We can now scroll to the data attribute. Let us navigate down. What you see here is the instruction to execute the code in the smart contract. The content of this field does not make any sense to us because this is machine-readable code and not human-readable. At this point, you may be wondering what is the purpose of the smart contract example that we just reviewed. The Associated Press published the results of the 2020 presidential election, as they were called state-wise, to Ethereum. The smart contract address that we just viewed was where the results were placed. The decision to call a state for a particular candidate occurred completely outside Ethereum. This decision was made by AP journalists who were specialists in predicting results based on voting counts as they emerge. Next, we will see how the presidential election smart contract worked. Let us go back to the contract address for the presidential election. We see 62 transactions associated with this address. One of these transactions, we just learnt, created the contract in the first place. The remaining transactions triggered the execution of the code in the contract. Next, we will open one of them to understand how these transactions worked. I now open one of these contract execution triggering transactions. The attribute of the transactions open up. I scroll down and expand this window to reach the data attribute of this transaction. We obviously cannot understand the machine-readable code. But I can click on Decode Input Data and see a human-readable version of what is in here. We can see that this transaction is instructing the smart contract to pull the data on the winner of the election for the state of Georgia. The source from where the smart contract pulls the winner of the presidential election resides off-chain, in the database of the Associated Press. Sometimes, the smart contract code may directly reference an off-chain data source. In other cases, a smart contract may source the data from another Ethereum address, which then sources the data from the off-chain source. So let us revisit the process flow. First, the journalists of the Associated Press determined who the winner of the presidential vote in Georgia was. Then, they updated an off-chain database with the winner of the Georgia election. Next, they sent a transaction to the smart contract address which contained instructions to execute the code with the input parameter of the state being Georgia. Finally, Ethereum miners received the transaction, the code was executed in each node and the result stored in each node within the contract address itself. Let us go back to the smart contract example. Why do we have 62 transactions? There are 50 states and Washington, D.C. that makes 51. An additional transaction represents the election results for the country itself. That is 52. Add one transaction for the contract creation itself and we are at 53. The balance 9 transactions were some duplicative and test transactions that were made. Every time a transaction was sent to this contract address, the code in this address was executed in each Ethereum node and the result was stored in each node within the contract address. So, what is the benefit of placing the election results on the Ethereum blockchain? After all, one could get the results in a human-readable form from many other sources. The point of demonstrating this example was to simply understand the functionality and concepts around smart contracts. We don't need to worry about the benefit of individual use cases at this stage. In the example we just saw, a currency account owned by the Associated Press triggered the execution of a code in a contract account. Sometimes, a currency account triggers the execution of code in one contract account, which in turn triggers the execution of code in a second contract account. There can be a long chain of contract accounts. However, the ultimate initiator of a smart contract execution will always be a currency account. In the previous lesson we learnt that currency accounts are called externally owned accounts. We can now discern the intuition behind it. A currency account is owned by an entity that is external to the Ethereum blockchain. It could be a human being acting in an individual capacity or on behalf of an entity. A contract account, on the other hand, is owned by another account within the Ethereum blockchain. No action can be directly taken from a contract account. Hence, a contract account is not externally owned. Since one cannot initiate action from contract accounts, they don't have private keys. The example that we reviewed illustrates the importance of a very important concept in Ethereum, that of oracles. For the smart contract example we reviewed, the execution of the code required a data source outside Ethereum. In our example, It was a database within the Associated Press. Service providers who specialize in procuring off-chain data sources are referred to as oracles in the Ethereum ecosystem. We will learn more about them later in this course. The purpose of this lesson was to get a real-world feel of Ethereum. In the next lesson, we will learn how Ethereum operates and in what ways are its operations, similar and different to Bitcoin. Before proceeding to the next lesson, review the summing up section of this lesson. See you soon.